You've done these before. I'm guessing you might have a meta interview coming up. Do you want to give any details about that? Like, is this a screening round? Is this an on-site round? I'll try to judge
Um,
accordingly because there is a difference in hiring bar for both.
sure. Yeah, so basically like last year around last year maybe around like September I did interviews. And then it was like a close miss. So the recruiter actually reached out to me and then
Mm-hmm.
she's like, yeah, so like to interview. So I'm in the first interview coming up on the 24th of February.
Gotcha. Gotcha.
Yeah.
All right, understood. Okay, cool. So meta coding interviews, basically you're gonna get 35 to 37 minutes. I'm gonna ask you two questions. And Essentially you're not allowed to run your code. You are allowed to do a dry run by
Mm-hmm,
creating
mm-hmm,
your own test cases, okay?
mm-hmm,
That's about it. I will spend about 20 minutes after the interview giving you all kinds of feedback. And because you're familiar with the platform, you know that the you can obviously listen back to it later on. I will submit every piece of feedback that I'll give you in the written format as well, so you don't need to necessarily write things down, okay?
mm-hmm.
But that's on you. All right, let's begin. Which language would you like to code in?
Python, yeah.
All right, that's good. Uh, okay, then let me give you your first question. Um, so, are you familiar with linked lists?
Yes, yeah.
Oh, all right, cool. So that's your first question. Have a read. Let me know if there's anything that's unclear. Happy to elaborate further.
Okay. So given the head of a singly linked list, so singly linked means there's one connection from the previous node to the next node. Group nodes, odd indices, followed nodes, even indices, return reordered lists. Okay. So we have a singly linked list. We want
Mm-hmm.
nodes, odd indices first, all of
Mm-hmm.
them first, and then nodes, even indices after all of the odd indices, and then we're going to return reordered list. So we still want a linked list, right? At the end?
Yep.
Okay. So want linked list. Okay. So first node considered odd with I guess with a value of one. Second node is even. Relative order, even odd groups remain as in input. Okay, got it. Yeah. So we have a linked list with nodes like one, two,
Mm-hmm.
three, four, five, and we
Mm-hmm.
want all of the odd ones first. So one, three, five, and then
Mm-hmm.
two, and then four. So we want this one.
Yep.
Cool. So since the first node is always odd, we can just
Mm-hmm.
return the same head, right? Okay. Cool. Yeah, so how would we do this? So, let's see. So one has to be connected to three, and then three has to be connected to five, and then five has to be connected to two, and then two has to be connected to four. Okay, so I think essentially, uh, yeah, so I think we can do this by first having a pointer for the even and the odd that we haven't added. So for example, the odd will be here and the even will be here. And then we'll connect all the odds first. So odd dot next would be odd dot next dot next. So
Mm-hmm.
it would be this. And then this would be canceled.
Mm-hmm.
And then odd dot next dot next. Odd dot next is two steps up. So again, it's here. And then since odd dot next is none, we must have finished going through all the odds. And
Mm-hmm.
then so the odd dot next is now going to point to our even pointer. So 5 times 6.
Mm-hmm.
And then we check, do we still have even nodes to add? If the next dot next add the next exists, then yes, we do. So the 2 gets pointed to the 4. And then we say, hey, do we have any more even pointers? Even dot next is existing, but even dot next does not, so we must be finished. So
Mm-hmm.
we can just do that, and then we can return the same head. Yeah. Yeah. So
What would be the, yes, sorry, go on.
oh, sorry. Yeah. So the time complexity in this case would be O of n, since we
Mm-hmm.
just iterate each of the nodes once, and the space in this case would be constant, since we're not using anything. Yeah.
Okay, sounds good. I think that sounds good to me. Let's see the code for this. And you can assume the usual. So you can assume that you have, let's say, a list node class. So that's what your head object is like, and it can have the usual value and the next pointers. Okay, those attributes are available. So you don't need to code up the class structure.
Got it. Got it. So define my function. So reorder, which takes in the head.
Mm-hmm.
So first, we're going to define our left pointers. So left is equal to head. And then we're going to have the right is equal to head dot next. Um, and we also have the edge case where we just have a single node. So if head dot next is none, then we can just return the head as we have finished. So we have the head and we have the head dot next. And so first wire left odds uh, odd and then even. So wire the odds. So what is the condition for wiring the odds? If odd dot next exists and odd dot next exists. Odd dot next is the next even element if the odd dot next is the subsequent odd element. So if this exists, so while this exists, we want to continue. So both have to be true. Okay, so let's wire it. So odd dot next is equal to odd dot next. And then we move the odd dot next odd 2 dot next is equal to odd dot next, and then odd. So 1 gets pointed to 3 equals odd dot next. So we just move it forward. Okay. Yeah, so when we finish this, 1 gets wired to 3. Um, it exists, so we get wired to 5. The next does not exist, so we finish. Okay, so now we have to wire the evens. So while even.next exists and even.next exists, so is equal to the first even. So the first even would just be at E. Mhm. Yeah, so we have all the odds wired up, and then we have the last odd wired to the first even, and then now we're going to wire all the evens together until the end. So this should be just the same logic. So E dot next is equal to E dot next dot next, and then E is equal to E dot next. Okay, and then we return head. Yeah, so this should be the general structure. I can also trace examples from now on.
Yeah, yeah, let's do that.
Yeah. Okay, so I will trace the same example. So here is not the base case where we just have a single node. So we have odd starting at the head,
Mm-hmm.
and then even is head dot next. So
Mm-hmm.
let's start with the odds. Odd dot next is existing, and the second one also existing. So odd dot next is equal to 1, 2, 3, and then move odd to this one. Okay, and then keep going. So odd dot next exists, and the second one exists. So 3 gets wired to 5.
Mm-hmm.
Then odd goes here, and then all dot next is false now, so we exit the loop, and O dot next is equal to 2. When we
Mm-hmm.
wire the evens, so E dot next exists and the second one exists, so let's move that forward to positions,
So
and then, yeah.
how is E dot next? What should be the value of E dot next here? Is it 4?
Uh, so in this one, right?
Yeah,
So
the
for 4.
operation that you just did. Yeah, why is it 4?
So we have the E here. So E dot
Yes.
next and E dot next exists.
But
So,
but isn't what is 3 pointing to now? Did your first loop not change things?
oh yes, so 3 is now pointing to 5. Yeah, so, right. So 1 is pointing to 3, 3 is pointing to 5. Um, oh, that makes sense. So actually, I think we have to, starting with the odd and the even. So basically, we have to move the even first 2 positions and wire it. Let's see here. Yeah, so in this case, I think it's not working because we're doing it one at a time. We should actually be moving them together. So, for example, if we're starting with this, odd should be going to 3, and then even should be going to 4, and then we move the odd up. So 3 should be now pointing to 5, and then keep going, kind of like weaving, and then we should basically just splice them together at the end. Yeah. So
Okay.
yeah, so I think I can implement that. So
Mm-hmm.
yeah, so first we move the O. Let's see here. O is equal to next dot next. That goes here. So 1 gets pointed to 3, and then E goes to 4. So 2 gets pointed to 4, and then O goes next dot next. So it gets pointed to 5, and then E gets pointed to end. And then we can get the end of the odd, which is 5, and point it to the first one, which is dot head dot next. Yeah, so I think that should be fine. So what is the condition here? We want to keep wiring the evens while there is an even, and then we want to keep wiring the odd as we have an odd, and then we're going to keep continuing, but let's see here. Yep, and I think we can use the odd as the parent condition since it's always going to come ahead of the even one. So I think we can get rid of this. And then we can say odd dot next goes to odd dot next dot next and move odd up. And then even dot next is equal to this, and then move the even up. And then since odd dot next exists, move the odd. And then the even gets also moved up. Yeah, and then so we have to connect the last odd node to the even node. So the last odd node is just going to be at O. Next is equal to the first even node, which is head dot next. Yeah, I think this should be handling that edge case there.
You want to do a trial?
Sure, yeah. So, okay. So O goes to head, even goes to head dot next. So while O dot next exists, so the two one up exists. So one gets pointed to 3, and then odd moves up here. And then even dot next to next also gets moved up. So even goes to here, and we have 2 going to 2 going to 4. We have 2 going to 4, and then so the second one exists. So this 3 gets pointed to 5. Odd goes to 5. And then even dot next goes to null. So we get none, and then even goes to none. So at this point, we have this. So 1, 3, 5. And so we can say the current position of the odd, which is at the last,
Mm-hmm.
gets pointed to the
And,
first
where is
first
head?
even, which is set. Yeah, so head is at the 1. So we want to point the final value of odd to the first even, which is head dot next, so which is 2. So 5 gets pointed to 2, and we should have this.
Okay. Do you want to do any other test cases?
Um, yeah, so if we just have a single node, that's just a base case. So if we just have one, head dot next would be none, and then we can just simply return this, and we would be finished. Um,
Anything else that comes to mind?
yeah, so I'll just do, let's see. So right now we have an odd number of nodes. So another one would be even. So for example, if we have 1, 2, 3, 4, so we should be odd, odd and even. So the second one up from odd exists. So in this case, 1 goes to 3, and odd moves up, and then even moves up. So 2 goes to 4, and goes here, and odd that second does not exist. So we would exit. And so odd dot next is equal to, so odd dot next is equal to set dot next, which is 2 in this case, which is already linked to 4. So this should be fine. So we have the odd elements first, and then we have the even ones. Yeah.
How is your head dot next not changing?
Oh yes, the head dot next should be now wired to 3. Yeah, so it just seems that we need to save the head of the even ones, which is just we can just say even head is equal to head dot next, and we can just save that node here, and then we can wire the odd dot next to even head. Yeah, just like that.
Okay. I think let's move on to the second question.
Yeah. Do you mind if I just go to the washroom very quick?
Sure, sure, sure. Take it time. Yeah.
Thanks. Thanks.
Yeah. All right. So should I move to the next question?
Yep.
All right. Cool. Second question is around binary trees. Again, have a look.
Mhm.
And just so that it's a little bit easier, let me just draw up one of the binary trees for you.
Sure, sure, sure.
There you go.
Okay. Yeah. So for this problem, I think it's best to first define what a binary search tree is. So ST is so for every single node, its left child should have a value that's strictly less, and then the right child should have a value that's strictly greater. Um,
Mm-hmm.
and this should be true recursively for every single node. So for five,
Mm-hmm.
the value should be smaller than five, uh, but of course greater than three. And then for seven, it should be greater than five strictly. So essentially, the problem asks us to validate if it's a BST. So we need to ensure that this condition holds for every single node recursively. Uh, so that's the problem. So essentially, what we need to do is every time we go down a node, we need to define the valid space of numbers that's allowed according to the definition of BST. So for three, we're allowed the elements everything less than three. So we can say have the range going into the left child as negative infinity to node minus one going into this one. And if it's in that range, yes, it is because the upper bound is two. It's valid. So it returns true for the left child. We go to the right child. That's looking for elements one, three plus one, which is four all the way to infinity. And that again fits the condition. Um, so 4 to infinity going down to the left child, now it should be less than 5, so it should be 2 to 5, 2 to 4, uh, and that's valid. Uh, and then going into the 5, the lower bound now is 5, so it should be 6 and up. So this is also
Mm-hmm.
valid, so we can solve it in this fashion, yeah.
Okay. What would be the answer for the given tree?
So the uh, given tree would be false because the lower bound here is 3, uh, and then
Mm-hmm.
the upper bound is 5. So this node would make it fail. Otherwise, if it was like this, it would be fine. Yeah.
Okay. Sounds good. Let's see the code for this. By the way, is
Okay.
there what kind of traversal would you be doing for this?
Yeah. So I would be doing a DFS for this one. Yeah.
Okay. And what's the time and space complexity here?
Yeah. So every node is being visited once. So the time complexity is O of n, and then the space in this case would be, in the worst case, it would be O of n if we just have a single like a linked list sort of structure, then it'll be O of n. But if it's kind of balanced, like the one we see here, then it would be log of n, or
Okay.
yeah, the stacked up.
All right.
Yeah, yeah.
Yeah.
Cool.
Sounds good. Let's see the code.
Okay, it's valid. Head. So let's say so this is the outer problem. We're going to define a helper function which takes in a node
Mm-hmm.
and it has a left and a right.
Mm-hmm.
Uh, so we'll just say low and high.
Mm-hmm.
So if not node,
Mm-hmm.
then we can return true since we expect that a single node is a valid BST. And then
Mm-hmm.
if in the recursive case, so check if node value is in between low and high. So if node.val is, so in this case, we're going to be doing it inclusive. So if the node.value is inclusive of the two range, then we can return true. Okay, so we have the answer for this node, and then we can, so if this node, for this node, if the node is in range, and also we need the answer from the children, so helper.node.left. But when we go into the node.left, the low is the same, and then the high should be node.val minus 1. And then we have another helper function going to the right child, so node.right. And then for node.right, every value should be strictly greater. So the lower bound should be node.val plus 1. And then the upper bound should just be the same. So I. Okay, and then we get the answer for left and the right. And then from this one, we can return. So if the current value is valid and the children are valid, then we can return true. So for example, in the case of 2, both of the children will be null. And then 2 itself, if it is valid, then we can return true and false if not. And then for 7, both of them will be true, and this value is in range, it can return true. And then, yeah, so we can check between the children and the node itself. So let's see. So we can return uh, left and right and so we can do this. Okay. And then now we call the helper function, which is called on the head. And then for the first value, anything goes. So we can say inf as the lower value, and then the float of inf as the positive value. So going into the 3 node here, we have all the space available. So the first node is going to be in range, and then we call it on the children to get the left and right. And if those are valid and the node value itself is in range, we can return true. So we have the answer here. Yeah, so this should be good.
Okay, can we do a dry run with some test cases here?
Sure. Yeah. So I'm just gonna do the test case at the bottom.
Mm-hmm.
Okay. So our state variables are node to indicate the current node that we're traversing. And then we also have a state variable low and high. So I think in this case, I'll just list the state variables beside each of the nodes in the tree. So the 3, which is the head, is being called on negative inf and
Mm-hmm.
inf. So it's going to be, so the 3 node here is going to be in range. So the ands here will be true. And then we call the left. So the left is being called on the same negative inf and the node.val minus 1, which is going to be 2. Okay, so again, this one is in range, and then we're going to call the left child. So the left child is going to be called on node.left is being called on the same low and node.val minus 1. So which is going to be, so minus inf and node.val minus 1 is 0. So in this case, 2 would be false. And then the right child would be the node.val plus 1, which is going to be 2, and then the high is going to be oh yeah yeah, I think the spacing kind of threw me off. So yeah, so 1 would be in range. So again,
Mm-hmm.
yeah, 5
Maybe
goes
let's let's
from
let's let's write it down. It might be easier to write it down as you were writing, and you can just create more space between them. or you can just
Sure, sure,
write
sure.
down the states for each of them below it. Either way
Sure, sure,
works.
sure, sure. Sure, sure, sure. Yeah, so 3 is minus inf to inf, so ans is equal to true. Um, and then left, right. So left is 1, so the bound for that is going to be minus inf. And then the high bound is going to be 2. So and is equal to true. Since the value is 1, it has no children, so both of the left and right are true, so 1 is going to return true. Now let's go to node 5. Node 5 is a right, so it's going to be called node.val as a lower bound. So which is 4, node plus 4, node plus 1 as a lower bound, and then the high would just be same, so it's inf. Okay, is 5 inbound? Yes, it is. So and is going to be true. Now let's go to the left child, is going to be 2. The value for that is the left child, so it's the low, which is 4. And then the upper bound is going to be node minus 1, which is also going to be 4. So and is equal to false. And then we go back up to the 5, and then we go to the 7, which is the right child. So the right child is 7. So node.val plus 1, so in this case it's 6. And then the high for node 5 was infinity. So for the node 7, the value 7 is in range, so it's true because it's in between 6 and infinity. It has no children, so 7 is going to return true. So for the 5 here, the left is going to be false, the right is going to be true. And since we're returning left and right and, it's going to return false. Uh, and then for the 3 node here, the left is going to be true, as we figured out in node number 1, and that the right is going to be false. And since for this one, we're returning and left and right, we're going to return false. Yeah. So this ultimately returns answer false. Yeah.
Got it. Do you want to try any other test cases?
Um, yeah, so we can try the case where we just have a single node. So that's going to return true. Um, let's see here. So I think some good test cases to try will be maybe when we have a skewed binary tree. So if we have something like this,
Mm-hmm.
so case where, for example, the answer is true, so something like this, uh, and we skew it a little bit. So for example, 3, so left is equal to minus infinity, and infinity, so and is equal to true. And then the left is none, so it's going to be true. And the right is going to be 5. So let's go into the 5 node. So the 5 is the right child. So we go node.val plus 1 as the lower bound, which is 4. And then the upper bound is infinity. So the 5 is inbound. So we say and is equal to true. And then the left is true because there's nothing there. And then the right is going to be node number 7. So when we go into the right child, the lower bound is 1 plus the parent node. So in this case, it will be 6. And then the upper bound remains the same. So in this case, it will still be infinity. So again, 7 is valid. The left and right is true since it has no children. So this guy returns true since everything is true. And the 5 element, so 7 is true, and then the left is none, so it's also returning true. And then the 3 node also ultimately returns true because everything, the ands, yeah, so it seems good. Yeah.
All right. All right. Let's stop here.
Yeah.
Before I jump to the feedback, how did you think you performed today?
I think for the linked list, Um, like I think I was focusing too much on wiring the pointers that I forgot that that essentially that the heads would have been rewired. And then if I kind of like zoomed out a little bit and saw that, I would have seen that you would need to traverse them together, so without messing up the traversal.
Hmm.
But I think
Hmm.
at the end I did get it. So yeah.
All right. I think overall this would clear both screening, like this will easily clear screening. For an on-site, I think there's a little bit of a doubt because of verification skills probably not meeting the hiring bar. Okay.
Uh-huh.
But for technical screening round, I think it easily clears things. The reason is, I think there are a few places where you're not being super proactive, and I have to nudge you. And when I nudge you, or when I ask you, when I prod you, at that point, you're able to answer the questions, right? So I'm
Okay.
gonna go into more details.
Yeah.
So first of all, do you know that there are four axes on which meta interviewers judge your coding performance? Is that something that you're aware of?
Yeah, I think I heard of it. I'll just write it down and note it though in the future. Yeah.
Okay, sure. So let me specify how things go. There's communication access. Let me just put this in comments. Um, there's problem solving skills.
Hmm.
There's coding, and there's verification. Okay.
Hmm. Yeah.
Uh, Now, what's happening is within each axis, you're being judged for each question, right? So, for example, in
Right. Right.
first, I'm trying to see your performance in first question and second question, right?
Yeah.
The reason Meta is asking two questions is solely so that in case a signal was missing in first question, they can get the signal in second question. And also, if something was weak in first question, second question serves as a way to know, is that a pattern with you, or was that a one-off case, right?
Yeah. Yeah. Yeah.
So if it was
Got
a
it.
one-off case, we can kind of forgive you. Okay. Now the rating scale, also just mentioning this, is a scale of five, but instead of one, two, three, four, five, it's these terms. All right.
Hmm.
So you're
Hmm.
being rated insufficient, moderate. And just before I kind of jump into feedback, one more thing is the hiring bar, which is in screening. What you have to do is you have to be moderate or higher on verification or communication,
Hmm.
uh, and moderate or higher on problem solving and coding. Okay.
Hmm.
But for on-site coding rounds, you have to be solid or higher on each axis.
Right. Right.
Okay.
Right.
Simple as that. Okay. And what's happening is within each axis, let's say I'm giving you ratings for each question that gets
Right.
averaged out for your overall axis rating, right? So axis might be in this case, it could be solid or strong depending upon where the interviewer is feeling you lie more towards, right?
Right. Right. Right.
Hey, can you hear me?
Yeah. Yeah. Yeah.
Sorry, I lost you there. Maybe some
No
internet
worries.
issue. Okay, so how did you do, right? So in
Hmm.
communicate, a couple of good things. One is you, like in the first question, I intentionally did not give you a test case. Okay.
Right. Right.
Uh,
Right.
it could happen. And it's important to understand, do you create a test case to discuss the solution, right? It's good communication skills to do that because it's
Hmm.
always better to create a test case. You did that, so that was good. You did not jump to writing the code without discussing the solution, getting a nod from the interviewer, so that's good as well. Your language
Hmm.
is easy to understand, pretty clear, so no problems there either. And
Yeah.
you were using the common space to explain the solution. In communication, I've actually given you strong for both, right? Both for in both cases, it was pretty good, right? So this
Hmm.
is almost as good as you can get. The
Mhm.
reason I say this is as good as you can get is exceptional is a very, very rare performance signal, right? Exceptional
Mhm.
happens when a candidate comes in and they're able to solve both questions, suggest like rare hard approaches, even
Mhm.
write those down and finish everything up within 15-20 minutes, right? So
Mhm.
those
Mhm.
are cases where sometimes interviewers are learning a new technique or something new about the question and something beyond what they even expect. Okay,
Mhm.
so
Mhm.
don't go for that. You want to aim for getting strong on each axis ideally when you're preparing, right? So in the worst case
Mhm.
also you'll get a solid and you'll be able to clear the hiring bar, okay,
Mhm.
even for on-site.
Right,
So
right.
communication are already there, right? There's nothing wrong here, right? When we
Mhm.
go into problem solving skills, so problem solving skills, I've overall given you a solid, and the reason
Okay.
is let's go to question one, right? Question one, you figured out an acceptable solution without any hints, so that was good.
Right.
You
Right.
knew about linked lists, you were able to share time and space complexity yourself proactively. I did not ask them.
Okay.
So that gives you again a good point, and then you were quick at finding the solution. So here it was a strong performance. Okay, everything was good. I did not have to interfere. I did not have to nudge you. So
Mhm.
that's like strong signal is often given when it's a very smooth presentation, right? And
Mhm. Mhm.
emphasis on the word presentation.
Mhm.
Presentations are often one way, right? Where the other person does not have to speak much. So,
Mhm. Mhm.
so it feels more like that. That's when you get strong, right? That you're covering all the bases without me having to nudge you for anything. Okay.
Right.
So this
Right. Right.
happened in question one, did not happen in second question. Second question, I've given you a solid, right? The reason is
Mhm.
so you were able to, first of all, the good thing is you were able to discuss what a binary search tree is, so you knew the definition. So that's good.
Mhm. Mhm.
Um, Now, a couple of things that weren't great is one, time and space complexity. I had to ask you about it. With
Mm.
so if I would not have asked you, you were kind of wanting to jump to writing the code. The other
Okay.
thing is this is a very minor thing, but want to mention it. You assumed it's integers.
Mhm. Mhm.
Hey, can you hear me?
Yeah. Yeah.
I'm so sorry. I'm facing some weird disconnects today.
No worries.
So I
Sorry.
was just saying that for problem solving, second question, one thing was that I had to ask you about time and space complexity. So it's not as smooth a presentation anymore because it's a back and forth happening. The other
Uh.
thing was you assumed that it's going to be integers. You did not ask
Mm.
me. If you would have asked me and I would have clarified it's integers, then it's okay, right? If
Mhm.
I would have
Mhm.
said that it could be float, it could be double, right? In that case, some parts of your logic would also change, by the way. You're doing a plus one and minus one. Instead of
Mhm.
that, you might have done just a less than or greater than in your condition, right?
Mhm.
So
Mhm.
I think that those things I would expect again to get a strong signal you have to be great, right? You have to do all the things correctly, right? And you can't miss out on
Mhm.
these minor things. But you still
Mhm.
do get a solid because everything else was fine. Even if you required a minor nudge here or there, again, emphasis on minor,
Mhm.
then it's fine. You're able to solve the question, you get a solid, right? As soon as it's a major hint, or something like I have to really point out what's the issue, that's when
Mhm.
it kind of goes into the moderate territory from solid,
Mhm.
okay? So that's
Mhm.
usually
Mhm.
the difference between moderate and solid. So here, overall, strong and solid. There's a chance that somebody kind of pushes you down. So worst case, you get solid. Best case, on a day where interviewer is very happy with you, they might give you a strong also. Okay.
Okay. Got it. Got it.
Um, Coding skills. Coding skills. First question. Um, you took care of edge cases.
Mhm.
Readability is pretty good in your code. Good variable names, comments in the code, method name is appropriate. All of that is great.
Mhm.
You could go even better, by the way. You could think about doing type hinting and stuff. But it's
Mhm.
okay if you don't do it. You can still get like a solid or a strong signal without it also.
Mhm.
Now, uh, the reasons and coding speed is also something that is just on that front you're average, you're not better than average at this point. Okay, so you don't
Mhm.
get a
Mhm.
positive point, you don't get a negative point either. Now there were two logical bugs in your code. Okay, one was that you were trying to do both odd and even separately, which would not have worked.
Mhm.
And unfortunately, when you did your own dry run, you did not figure that piece out. I had to tell you
Right.
how is you even doing this, right? So
Mhm.
that's one thing. The other, there was another logical bug, which was the head dot next bit.
Yeah.
Now, after the
Yeah. Yeah.
first thing, the first bug, I pointed it out, but you corrected it yourself. You figured out the solution for it yourself. So
Mhm.
I was, hinting towards going solid for this axis, coding axis. But
Mhm.
then there's a repeated mistake that happens, right? With head dot next also, when I asked you specifically, hey, can you do more dry runs? There is
Mhm.
a reason why interviewer is trying to do that, right? Maybe there is something else you want to catch, right? But
Mhm.
then you did
Mhm.
not catch that, and I had to again point out specifically that how is your head dot next? Where is your head dot next? What is it pointing to, right? And when I'm being very specific about the issue, calling out exactly that there's a bug here, then it kind of goes a little bit into moderate territory. Okay, so
Okay. Okay.
so here what happens is question one, I've kind of kept it somewhere between moderate and solid. That's what I wrote down.
Mhm.
Question two, however, is on the other hand done much better. You took care of edge cases. Readability is good again. Code is correct. There is no issue in the code.
Mhm.
Coding speed is average in general, so nothing, no positives or negative there. And here again,
Mhm.
you get a solid slash strong, right? So overall, kind of becomes at access level a solid rating. Okay.
Mhm. Mhm.
Which brings me to verification. Now, verification first question is strictly moderate because you were trying to do a good line by line verification, but you did not catch up your own mistakes, right?
Mhm.
So
Mhm.
there are
Mhm.
two mistakes in your code, you did not catch them. What's the point of doing line by line verification if you can't catch your own mistakes, right?
Yeah.
So that's
Okay.
something, I think that's the biggest feedback for you from this mock, that try to be like when you're trying to do a dry run, forget any logic in your brain. Okay, you have to literally be an interpreter. Read line by
Mhm.
line and actually do that operation in the comment section here. Do not actually try to process anything in your brain. That's
Mhm.
the biggest mistakes people do, and that's why their verification skills are poor and they don't
Mhm.
get hired sometimes because of that. And that's pretty sad, right? Because you're able to code up things, you obviously know all the structures, and you're getting stuck just at verification stage, which nobody really has to do in their real job, right? So,
Mhm. Mhm.
so it's something that I feel the most sorry about, that this should really not be happening. And
Mhm.
I would encourage you that if you are really focused towards, doing well for Meta this time,
Mhm.
it
Mhm.
is important to spend, like when you're practicing questions on lead code in the next few days or
Mhm.
next couple of weeks, every question you do not click on submit button. Create 3, 4 test cases, do a dry run, and do a proper dry run. Try to catch the issues. If you don't catch the issues, and think of it like this, that you only get to click on submit button once, right? That's
Mhm.
the limitation you have, right? So it's kind of
Mhm.
similar to a real coding interview.
Mhm.
And once you click the submit button the first time, if there is an edge case that got missed, write it down. Write down what mistake you made, which kind of edge case did you forget about. Write it down in a Google Doc or a Google Sheet, or in a notebook, something that you will have a look at every single day before you start practicing more questions. Okay,
Mhm.
that is the only way you'll definitely imbibe this within you in the next 1 or 2 weeks. So
Mhm.
it's a more short way of kind of doing that and not making this mistake.
Mhm.
So that's that. That's why you get moderate here. You did create a couple of test cases, which is another checklist item that interviewers are looking for. Just the test case given in the question is not enough. You have to create few test cases yourself. Okay, so the
Mhm.
interviewer will always ask you, unless the time is out, interviewer is gonna ask you to do some test cases. But to go from a solid to a strong rating in verification, you have to do the test cases proactively. I should not
Mhm.
be asking you, right? So think about
Mhm.
that. To go to solid, you need to make sure you do line by line like an interpreter and you fix and find out the issues. And to go to strong, you have to create test cases yourself, right? I should
Mhm.
not be
Mhm.
asking you for it. Okay.
Got it. Got it.
Um, Second question is I was initially thinking it could be solid, but it's also moderate, and I'll tell you why. So in so first of all, I like the way you were trying to do visualization for the states for each number. It's very, very clean way of doing the dry run here for second question, among the cleanest that
Mhm.
I've seen for this question. So that's
Mhm.
nice. Um, you did not create a new test case yourself unless I asked. So that
Mhm.
automatically pushes it down to, solid. And then the other thing was that it would not be considered a proper line by line verification. So here's what happened, right? Once you finish the code, you did a first round of verification yourself by just skimming through it, saying with the test case, with three, this would happen, one, this would happen without writing anything down. And then you said,
Mhm.
yeah, this should work, right? Don't
Mhm.
do that. It's an anti-pattern.
Mhm.
Meta is asking you to do proper verification and you have to be patient through it, even if it's boring. So
Mhm.
don't say that this would work. Never say that after you've written the code that it will work. A better way to phrase things is, okay, I think this code, I think I've done the code as I thought it should be. Let me
Mhm.
try to now test it through dry runs and make sure that there's no bugs in here, right? And then you
Mhm.
start doing a dry run, do it properly line by line. And if
Mhm.
nothing, like after two test cases, let's say, there are no issues in the code, at that
Mhm.
point you can say something like that, okay, I think this should work, right?
Mhm.
And even then you should ask the interviewer, would you like me to test more test cases? And that's kind of,
Mhm.
nudging them to just say yes or no. And if they're saying yes at that moment, there is probably some bug in your code. Okay,
Mhm.
so that's a better way of directing the whole coding interview.
Mhm.
Just better way of getting the right answers without sacrificing your performance ratings for any question.
Mhm.
That did not happen here first, and then when you were actually doing a proper drive and after me asking you to do it with test cases, what
Mhm.
happened is you started doing it line by line, but when you reach, like again, I'm looking at line number 74 to 78, right?
Mhm.
So when you start going from three, then one, then five. Now,
Mhm.
if you technically go through your code, you cannot get an answer for five, like what it will return until you go through two and seven,
Mhm.
right? But you ended up not processing things that way. You ended up processing, okay, five will return true, and then you went to two, which is not
Mhm.
how your code actually goes, right? So again, you're not doing a proper line by line verification. Okay.
Mhm.
So
Mhm.
the expectation is you go line by line and see where it leads you.
Mhm.
And you can leave some of the variables in partial states if you don't have the
Mhm.
full answer right now, right? And that would make it a thorough verification. That's what
Mhm.
is expected. That's why you got a moderate here, because two times this thing happened and I had to prod you also.
Mhm.
So overall this verification access remains at moderate. Now, if you see the hiring bar that I wrote down,
Mhm.
wrote above, you'll see that you're obviously clearing the screening round with this performance. But for
Mhm.
on-site, it's a little bit difficult because verification is at moderate, right?
Okay. Okay. Okay.
So on-site, there is a chance that the interviewer, you know, gives you benefit of doubt,
Mhm.
but there's a 50% chance they don't clear you because they state poor verification skills. And that's so
Mhm.
sad,
Mhm.
right? And these are the kind of things that happen and then you get feedbacks from recruiters stating, you were very close to passing the round, did not happen. This is what's
Mhm.
happening. Essentially, you did well on few axes and one axis you were not
Mhm.
up to the par.
Got it.
So
Got it.
this is about it. Hopefully, this gives you a better insight into how you are being judged now.
Right. 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 Yeah. Um. Yeah, thank you so much for the thorough feedback. So it looks like I have to like focus more on tracing and like I
Yeah.
didn't really know that like it's a minus point against me if I kind of like don't do it proactively. So yeah, so definitely in the future I will be like the first one to suggest the test cases and then like
Yep.
do them and then kind of just ask like would you like more test cases from the interviewer?
Yeah. Yeah. It's always do it
Mm-hmm.
like that. Yeah. Just always
Okay.
try to be proactive. That's often, in fact, although for coding, leveling doesn't matter, but for all other interviews, except for behavioral, any system design interviews, any other kinds of interviews,
Mm-hmm.
often a big difference between E4s, E5s, or L4s and L5s is actually to how proactive are they, how much are they leading the interview themselves versus
Mm-hmm.
requiring the interviewer to help them or to nudge them or to have a back and forth with them, right? So
Got it.
the more you lead, the better you seem anyway as a candidate. So
Mm-hmm.
that'll always be better, regardless of which interview it is.
Mm-hmm.
Except for behavioral, right? Behavioral is one of those interviews where the questions would always be coming from the interviewer.
Mm-hmm. Yeah, thank you so much. Do you do any like I would like to practice more interviews with you. Like, is that possible?
Yeah, I think so. I believe there should be a way. One is so there are two ways around this. One is obviously dedicated coaching. I do dedicated coaching as well with IIO, and
Mm-hmm.
you could sign up for 3 sessions, 5 sessions, depending upon how many sessions you'd want, and we could
Mm-hmm.
turn those into design, behavioral, coding, or anything else you might be going for.
Yeah.
I've coached a lot of people from Meta as well as some from for Google OpenAI as well. So that's that. The other way would be, I'm not sure if interviewing.io, when you're booking just a regular mock like you did today, whether it supports booking it with a certain person. If it does,
It's
you
like
can always,
random.
yeah, it is random as far as I know, but you can always mail support at interviewing.io to check with them. If there is
Mm-hmm.
a way, you could just book it with me. There
Mm-hmm.
should be possibility of doing that, but you can just check with them, I would say.
Mm-hmm. 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 Yeah, thank you.
All right. Happy to help. Take care. All the very best. Bye bye.
Bye. Bye.